Welcome back to VMware Explore 2024. Thank you all so much for joining us today. Got a great session for y'all. We're talking about unlocking the magic of Gen AI with VMware VCF. So we're going to do a bunch of myth busting and stuff in here. I'm Tony Foster. This is my partner in crime, Gina.
Hello, I'm Gina Rosenthal.
So we do want to remind you, please take your surveys. Take one for this session and finish off the ones that are still in your queue as well. We as presenters greatly appreciate the feedback. So a little bit about us.
I can talk about me. So I'm the CEO of a fractional product marketing company called Digital Sunshine Solutions. I started that about 5 years ago. That's when I left VMware. I was in the CBBU business unit. I was a product marketer there. But I've been working with VMware since 2008 or so when I wrote labs for EMC. I was the first one to virtualize my labs. I also have a podcast called Tech Aunties, and you can find me on Mastodon, Gminx, or on LinkedIn.
Cool. I'm Tony Foster. I'm also known as the Wonder Nerd on all my social media platforms, hence the cape. You will always see me presenting in a cape, so I come dressed in a cape. You can find me just about anywhere under Wonder Nerd. Please feel free to connect with me on LinkedIn if you're interested. With that, let's actually get into the stuff you came to hear about. Here's our agenda. We're going to make it real quick and everything. So let's just get into the AI level set.
Right. So let's talk about the three types of artificial intelligence. And if you are an AI aficionado, you're going to disagree with this a little bit, but I'll tell you where I think you're going to disagree. It's okay. We're just bucketing stuff for the masses like me. There's actually three big buckets we can put artificial intelligence in. One is narrow AI. We're going to talk about what that means to be narrow. There's also artificial general intelligence. You might see that referred to as strong AI or AGI. You might have heard that term. And then the third type is artificial superintelligence, ASI. But the thing about it is, there's only one that actually is in use right now. The only one that we use is narrow AI. The other two are theoretical. So the other two are when the algorithms get to the point where they can do things the same way as humans would for thinking and creating. And actually the ASI one is when we get artificial intelligence that would be like Vision from the MCU universe or our Data from Star Trek, totally sentient. So we're not going to talk about this. We're going to concentrate on what's real in this presentation, which is narrow AI. So narrow AI is designed and intended to do one specific thing. It's programmed, everything that around it is for one specific task. That's why they call it narrow. It can only stay in that realm. It can't take any of the information it gathers, any of the work it does, and extrapolate that into something else. It can't think. None of the AIs can think. I'll explain that a little bit too. Excuse me. Here's the types of narrow AI. Tony's pushing me along here. These are, and you have used these. And you have products in your data centers right now that use some of these. The most basic is reactive. That's how computers can play chess, is reactive AI. Another good example that you probably used is really basic commands when you have a voice assistant. So if you say, hey, Google, set a timer for me for 10 minutes when you're cooking something, that's an example of reactive AI. Generative AI, how many of you guys have used some generative AI? That's the big, sparkly, exciting AI that we talk about a lot. What it's trained to do, its narrow focus, is creating content. And you may be like, well, wait a minute. It's creating all sorts of different content. How could that be narrow? The whole idea of being able to give it a prompt and get content out of it, that's what keeps it narrow. It's all just content creation. And we're going to exactly show you how those algorithms work in a minute. The next three, predictive, descriptive, and diagnostic, are all analytics types of narrow AI. So you probably have this in your security or maybe some of your storage. That's definitely some in, I believe in vRealize or whatever it's called now. So these are just the things that tell you. Predictive is like, okay, this happened in the past, so what do we think is going to happen next? So that's definitely like buying behaviors if you're a marketer like me, or if it are stock market trends. That's how they get that, is with a predictive narrow AI algorithm. Descriptive is all of your BI tools. So here's all the stuff that's happening in your environment. If they're using a narrow AI, it's a descriptive AI to do it. Diagnostic would be, here's all the stuff that happened, and here's what we're pretty sure will happen based on the trends from what we noticed in the future. All of those are, again, a narrow AI. And limited memory is probably one of the more complex of the limited AI. That's where you get the algorithms for self-driving cars. And as you know, that takes computer vision, that takes lots and lots of training for the car to understand from the vision where it is in a lane and what a person is versus something else. Okay.
So I thought you were finishing this off, but I'll go for it. Cool.
I was going to.
So generative AI is narrow AI. Gina just went through all of that. The reality is it can't do anything outside of its bounds. It can create new content from existing data. So everything right now that you get from generative AI, regardless of it's an OK Google command or, hey, ChatGPT, create a picture of a robot drawing a self-portrait of itself, is all coming from existing data. All of this stuff comes from somewhere. It's already been created. Generative AI is just coming up with a new way to put it together.
And if you've been working on these types of things, if you're a data scientist, you probably remember 5 years ago, and in our talk 5 years ago, in the title, which is the most horrible title I've ever given a talk, we had in the title HPC, deep learning, machine learning. This is really deep learning and machine learning. It's nothing new. It's computer science. And that's the thing we need to keep in mind. And that's really important. So we are not regenerating computers. We're not generating an AI to be something alive and do something, or undead, as the case may be. It is not science fiction. The only thing that's science fiction are the two that aren't in use yet that everybody wants to talk about. The ones that are in use is a version of computer science, and it's an extension of computer science. And to think about it, we're here at VMworld, so how many of you guys are operations people? Or manage operations people, right? There you go. So what we do is we make sure that we architect, design, manage, keep running the infrastructures to run workloads. Narrow AI is a workload that a data scientist is going to create from the right algorithms. They're going to pick all of that. We're going to talk about how it works. But this is just it's just an extension of what we've always done as operations people, is support the workloads that run on our infrastructure.
And it's just a workload.
Okay.
Thanks. I will. I think I will. I like this one. So what can the enterprise do with Gen AI? There's tons of stuff. You've all seen all of the amazing stuff that people are doing here. You've probably even been back here behind us doing some of the generative AI code labs in the back. So you've seen a lot of what generative AI can do. And what we have here is just a smattering that we're going to talk about. One of the most common ones, you probably have seen this on websites all over the place, are those little chat bots that pop up and say, would you like to talk with a chat representative? There in the lower right corner or whatever. Just customer support. Perfect use case for Gen AI. Makes it real easy. You can take a model, train it against all of your public corporate data, and let people ask away, make them think they're talking with a human. There's the coding assistants. You got to see that back here in the code labs. If you went to the hackathon, they did a lot with it at the hackathon. Spear phishing detection. This is one of my favorite ones. How many people get spam in their inbox, corporate or otherwise? Okay, I see about 2/3 of the hands going up, so I'm guessing the other third is lying.
They don't check their email.
That could be. Or maybe they have this already in place. One of the three. But spear phishing, you can use AI to proactively go through your emails and catch a lot of those spear phishing attempts. And the reality is the phishers out there are using AI to generate their emails to try and get you to give them money. Why not use AI against them to try and keep them from giving the money? So Last one, and this is probably Gina's favorite one, is marketing support. Let's leverage AI to tailor the experiences of those using our products so that they get the best experience, so that they are interested and engaged in those products.
Well, spear phishing is just a form of marketing. So
it absolutely is.
I think marketers also use it. I'm not very good at doing the fluffy marketing. I can write a document that everybody that's nerdy will like to read, but to catch your attention, I use AI because they do a better job than me. So it helps you write stuff.
So let's actually crack open the Gen AI recipe. What all do we need to go and create some AI? We're going to hop into that here real quick. So, of course, we've got to have data and storage. They go hand in hand. If you're going to create AI, even if it's a simple AI, you got to have data that you want to train it on. You can't just put a chat bot on your website and say, oh, this is good enough. Because if you start asking it about stuff, like, for example, this session right now, it's not going to have any context for it. You have to actually have the data so that it has context.
The context is important because it will make stuff up, right?
It will absolutely hallucinate on you if you don't sit there and give it context. And we'll talk about RAG here in a few slides, but RAG comes into play there as well. Then you need compute and accelerators. Johan van Amersfoort did a great session where he was actually talking about how you don't need accelerators to do AI, which is true. You can do AI on general processors. Intel even has some great processors now too that have some acceleration built into them. But in general, accelerators really help the scenario and make it a whole lot easier to work with. You need your algorithms, whatever you're going to be working with, NLG, NLP, or any of the other acronyms that are out there. You go looking, there are gobs of acronyms.
Your data scientists will figure that out.
Yes, they will. Then you'll need the frameworks, and we're going to talk about frameworks here in 2 slides. SLMs, LLMs, small language models, large language models, or what those stand for. RAG, all of that stuff. That all falls into that big frameworks bucket there. Then you have your pre-trained models. And this is what we're going to spend a little bit of time talking about on the next slide. The pre-trained models are those things that you can go out and purchase already. You can go out and purchase ChatGPT for your organization and build stuff on top of ChatGPT. So you can go out and get pre-trained models, which gets us to my favorite slide in the deck. We can, instead of trying to build all this from scratch, dumping all the ingredients in a mixing bowl and trying to get something, we can just buy the cookie dough pre-made at the store.
The one thing to be careful of, even with the pre-trained models, and I use, you can see this is from Sequoia Capital. It's just the section about the enterprise tools. There's sections for consumer and something else. But these are kind of the tools. You can see the marketing tools, search, sales, all the things you might want to use marketing. You might want to use generative AI for. So there's lots of examples here. And of course, you've got the big companies that have their own models that also have things in front of it. Like Microsoft has, I can't think of what it's called.
Copilot.
Copilot. Google has one. Of course, ChatGPT is GPT or GPT. The danger of this is, if you're thinking from a security and an operations side, right? Even from these ones that are SaaS products, they get access to all of your data, to all of your IP. So you have to be very careful and you have to pay attention that you're using them in the right way. So they're helpful for a company like me that's smaller, but you have to pay the enterprise fee for them so that you get the privacy piece. That's especially true. They don't really market this, I don't think, enough with the Google Helper and the Google Generative AI and the Microsoft Copilot. You have to have an enterprise license. You cannot use just the out-of-the-box license. If you use the out-of-the-box license, if you use the enterprise one, they put a filter between the trained generative models and your data. So if you give the model a prompt, instead of just going and searching from what has been trained on the whole wide internet, you end up going back through your content for the for the response. And it also doesn't get served up to be trained, so anybody else could potentially extrapolate your IP from a prompt that they create. So you have to really watch. These are awesome. I use Jasper AI all of the time for my marketing stuff, but you have to make sure you read how they're protecting your IP and what the security they put in place. Don't just use the free one and think that's awesome because it's free because you're giving them data to train their models with.
Absolutely. So let's talk about some of the free models that are actually out there that you can get. I do a lot of work with NVIDIA, so yes, shameless plug for NVIDIA, I guess. So we have NVIDIA Riva, which is great if you want to put in an operative system, like an operator to do phone support or even do your phone menu. It'll do text-to-speech and automatic speech recognition, or ASR. And so you can use that to actually sit there and build out a operator system, or even read scripts for videos and stuff. And it has a natural language and everything else to it. I actually worked on a paper with some of my colleagues at Dell on this that we've had at NVIDIA GTC. So it's down there on the bottom link. Then there's NVIDIA Triton. NVIDIA Triton is awesome for developing code. So a lot of coding platforms where you're using AI to generate code have this as a base module. And you can go in, grab this, plug in what language you're using, and then do prompt language or prompt programming. So instead of actually having to know the language, you prompt it on what to write, then you review it for hallucinations and stuff, and run the code. And the last one's NVIDIA Morpheus. NVIDIA Morpheus is the base, or Morpheus, I'm sorry, is the base for phishing detection. So really powerful set of modules that you can get for your AI environment. Literally go out to NVIDIA. These links will take you right to it. Download the models, and it walks you through the setup of those, and you can start small and then continue to scale. So let's talk about how large language models work. We're going to go inside the black box of a large language model, or any AI really. Let's say we've got this picture up here of a cat, and we're going to put that through the AI model here. Right. My green arrows aren't showing up worth a darn. So we put the picture of the cat through the AI model, and at the bottom it says cat, C-A-T. This is a cat. How does that work? We're going to actually crack open this box, and this is how it works. This is the magic. And everybody's like, oh my gosh, this is so complex. I don't understand it. I don't understand it. It's actually really easy. It's based on a lot of code, tons and tons of code. And what I typically tell people, especially people who aren't nerdy, is it's a large statistics problem. It's got multiple nodes of statistics problems going on. They basically want to solve for the probability of X being the case. In reality, it's a large linear regression model. Now, this is actually broken out into layers. So an AI model has tons of layers. You have an input layer, an output layer, and hidden layers in between. Hidden layers are where most of the work happens. And each hidden layer has a weight, i.e., how much do I trust that particular response from that node, and then node or cell technically, and then they have their output, and that's another number. That's the basically linear regression answer to the problem that they were posed, or to the statistics equation, however you want to look at it. It takes all those things together, aggregates it, and kicks it out on the output cell and says, this is a cat, not a dog or anything, and I can say that with a certain percentage of certainty.
So I'll just say a couple things really quick. We're talking now about how this works and if you're going to build this on-prem and how it's going to work for you. There's things to keep in mind. Make sure the model that you get is going to do the job you think it's going to do, right? So you want to, if we want to figure out if the cat's really a cat, you're going to need an LLM. How was the model trained? Was it trained responsibly? There's no standards to tell us that right now, so you're going to have to do investigation. Can you trust the training data? Probably not, because most of the LLMs were trained on the entire internet. Think about what's in the entire internet, and that's why you shouldn't trust it. But there's ways to mitigate that, and Tony's going to talk about that next slide. But also, if you have if your work has a ESG policy, and you're worried about societal impacts to things, or you're worried about the energy impacts to things, these can have an impact on your ESG policy. So you want to look at that. There's a great paper about the dangers of large-scale LLMs. If you look up stochastic parrot and LLMs, that paper will pop up and you can check that out.
Awesome. So let's talk about RAG. Everybody here has been talking about RAG. There hasn't been a day that's gone by where somebody hasn't talked about RAG. And we're going to actually talk about what retrieval-augmented generation actually is, aka RAG. Now, the best version of this that I've ever heard, read, or anything else comes from a great NVIDIA article. And it's linked here on the slide. But the way RAG works is, think about a judge. A judge gets a docket of court cases. And that judge can sit there and use their experience, use their reason and everything that they already have to make decisions on those cases so that they can issue fair and equitable judgments. Now, let's say a case gets added to that judge's docket that the judge doesn't have a lot of experience with. Maybe there's new case law showing up every day. What they'll do is they will send it to a court clerk. The court clerk's going to go out and research case precedent and everything else for the judge. Then, once the court clerk has finished reviewing, it's going to come back to the judge and say, here are the summary documents that I found, here are all the citations and everything, and here is the precedents and stuff that you need to be aware of. The judge can then issue a decision in the case based on that, and can cite the sources for their decision. They can say, in this case versus this case, here's what I want. And that same model is true with RAG. RAG sits there and will send out a clerk. RAG is just a clerk going out and gathering information and then returning it to the model. And it can actually cite the sources where it got information for you, which, going back to Gina's point slide ago, is really important when you have to know where your data came from and be able to justify the reasoning behind it. So let's put this all together real quick. We've talked through all of this stuff. The one thing we haven't talked about is training and VCF. So we'll get to VCF on the last slide. Let's say we want to train a model. How does that actually work? Well, the reality is we get a big set of tagged data. Anybody who's ever had to fill out the Google Forms, identify all the buses in this picture, thank you for tagging data. You tag data and run it through, check yes or no for cats. It'll tell you what percentage it is. And then if that training is acceptable, great. If it's not, we're going to go back through and retrain it. We're going to tweak some of the numbers and stuff we talked about earlier. If it's acceptable, though, we're going to go put it out in production. And we're going to be able to look at all these different pictures up here and go, are they cats? Are they dogs? Or is it something unknown? And by the way, that's Gina with
Jason on the left.
Yes. So that gets us to VCF really, really quickly. Start with the small stuff, the low-hanging fruit. Don't try and tackle more than you can. Virtualize your AI workloads, as you heard during the keynote. They're at or better than bare metal. Then expand to the edge. VCF makes that really easy to do. And lastly, monitor, adjust, and repeat.
Just like we've always done.
Yes. So with that, thank you everybody for attending the session today. Please complete your survey. Slides are available on my website, wondernerd.net, and Gina's website, digitalsunshine.com. So thank you all.